Okay, here we are given a problem where we are supposed to show each of these functions is equal to tan square A. Now in such problems, always take the first part and show that it is equal to tan square A, and then take the second part and show that it is equal to tan square A. Okay, let us start with the first part, which is 1 plus tan square A by 1 plus cot square A. Now we all know the identity secant square A minus tan square A is equal to 1. From this I can write secant square A is equal to 1 plus tan square A. As a result of which you can see that 1 plus tan square A is secant square A, and here we have 1 plus tan square A. Now I can replace 1 plus tan square A with secant square A. Similarly, we have another identity which is cosecant square A minus cot square A is equal to 1. From this I can take cosecant square A is equal to, bringing cot square A to the right hand side, becomes 1 plus cot square A. So that 1 plus cot square A is cosecant square A, and I can put that value here. As a result of which 1 plus tan square A can be written as secant square A, and 1 plus cot square A can be written as cosecant square A. Since both terms are having squares, I can write it as secant A by cosecant A whole square. Now we know that if you are having proper understanding of all the trigonometric functions, you can actually write secant A by cosecant A as tan. Otherwise, convert them into sine and cos terms. Secant A is 1 by cos, whereas cosecant A is 1 by sine. Now this is the form A by B by B, C by D, which we can write it as sine A by cos A whole square, which is nothing but tan square A. Right. This is the first part of this question. Now let us look at the second part, which is 1 minus tan A by 1 minus cot A whole square to be shown equal to tan square A again. Now in this case, here we are given everything in terms of tan and cot, and the answer is supposed to be in terms of tan. So let us convert this cot function into tan function. So we can write this function as 1 minus tan A by 1 minus cot A is nothing but 1 by tan A whole square, which is 1 minus tan A. Let me separate the squares whole square by taking LCM here. We get it as tan A minus 1 by tan A whole square. Now since it's a square term, tan A minus 1 can also be written as 1 minus tan A. So I'll write it as 1 minus tan A whole square by 1 minus tan A whole square by tan square A. Now taking this denominator of denominator to the numerator, we get this as 1 minus tan A by 1 minus tan A whole square into tan square A. Cancelling this out, we get 1 square, which is 1, into tan square A, which is tan square A. Therefore, we are able to show both the first function, which is 1 plus tan square A by 1 plus cot square A equal to tan square A, as well as the second function 1 minus tan A by 1 minus cot A whole square equal to tan square.